Newton's laws, also known as Newton's laws of motion, are three principles from which a large part of problems posed in classical mechanics are explained, particularly those related to the movement of bodies, which revolutionized the basic concept of physics and the movement of bodies in the universe. Newton's laws are one of the greatest discoveries until today. These are applied in many aspects of our lives, from when we ride a vehicle to reach our destination, push a simple box, or do not even have to do anything. The universe, our environment, is in constant motion.
At this stage, we will study two dynamics, which deals with the study of how the movement originates and it changes. You have to keep in mind several concepts: mass, acceleration, inertia, weight, strength, balance and no balance, free body diagram, uniform movement, etc. In the following video, we will represent some explicit representation of how Newton's law works and how they look in reality. Our purpose is to show how real the mechanics is and how simple it is to apply in the reality and in our daily lives. Next, we will mention to you what it is that each one of Newton's laws together with their applications, in addition to showing an example in the real life.
Newton's first law, also known as the law of inertia, tells us that if not other acts on a body, it will remain indefinitely moving in a straight line with constant speed, including the state of rest, which is equivalent to zero speed. As we know, the movement is relative. That is, it depends of which observer describes the movement. Newton's first law tells us that for a body to alter its movement, it is necessary to there be something that causes such change. That something is what we know as forces. These are the result of the action of some bodies on others. Here is an example of what we did in real life, of the team representing an example of Newton's first law.
As we can see, the car is in a state of rest where its speed is zero. At the time we arrive and apply force while the car is in neutral. It moves as a result of the applied force and leaves the resting state.
Newton's second law, also known as the fundamental law of dynamics, is what determines a proportional relationship between force and variation in the amount of movement or linear momentum of a body. In other words, is the force is directly proportional to the mass and acceleration of a body. Newton's second law is responsible for quantifying the concept of force. It tells us that the net force applied to a body is proportional to the acceleration that body acquires. The constant of proportionality is the mass of the body, so that we can express the relationship as follows. The formula: force is mass for acceleration. We also present an example of this law, we show you below.
For this, we have a bucket with water, which has considered weight, and for this, your partner will apply forces to move that bucket. When applying forces, this influences the weight of the bucket, the friction force with the ground, and the same force to determine the speed at which the bucket moves. Finally, this one moves.
Newton's third law, also known as the principle of action and reaction, tells us that if a body A exerts an action on another body B, it performs on A another action that is the same and in the opposite direction. In more explicit terms, the third law states that for each force acting on a body, it performs a force of equal intensity and direction, but in the opposite direction on the body that produced it. That is, the forces always appear in pairs of equal magnitude. Opposite direction are located on the same line. It should be noted that, although the action and reaction pairs have the same value and opposite senses, they do not cancel each other out, since they act on different bodies. Similarly, we attach an example.
In the first video, we can see that two of you are the edge and pushing the rope with the same force. This means that both forces are null. In the second segment, there is one of you on one side and three on the other. This applies the same force. This is the action, and the reaction is that where there is only one companion, this will be dragged to the other side. Since there is greater force on the other side where the three are applying force to that vector.
Isaac Newton is one of the fathers of modern science, and thanks to him, some of nature mysteries and many more unknown have been explained to the application of his laws along with others. The discoveries of the scientists have explained the existence of gravity, that of the movements of the planets, etc. That's why Newton's laws have that historical and scientific value. They are part of the great important discoveries that only a few people can achieve. For this and other reasons, he managed to develop laws which have helped us a lot with laboratory resources that we will consider precarious today.
Newton's laws are very important because they allow us to understand, explain and predict many natural phenomena that relate strength and movement of bodies moving at relatively small speeds. All movements that occur on Earth and the universe can be explained with these laws. Therefore, they are related to what happens in our environment and have practical application in daily life, in the natural sciences, the engineering, and technique, etc.